Okay, so I guess that you can see my slides. So welcome everyone to the Kiali and Jaeger Sprint 49 summary and demos. So today we are going to have with us to Xavi and Gary that will present and demo some feature on Kiali and summarize what we're doing in Jaeger side. So let's going to start with some summary of the Sprint 49. So as always, so thank you for all the community and all the activity that we have around the project. So this time I would like just to give you a little bit of numbers of the Sprint 49 that what we have accomplished or achieved on this sprint. So we have 7 epics in progress. The epics is the concept that we call some X tasks that can involve several sprints. In this sprint, we close 23 issues. Also, we merged 35 pull requests, probably more because I only count the backend and frontend, but I didn't count the operator or the help chart, so probably around 40 pull requests merged. And the most interesting thing is that the community is growing, and just looking the new issues created in the project, more than 22% of these issues came from the community for new users that are filling new bugs, are filling questions, are just asking for an SMS or new features. So thank you a lot, and thank you for participating in the project because we take your feedback very seriously, and we like a lot how you are involved with the project. So yeah, what more about the highlights about this Sprint 49? We are going to present to demo some of the features that you will see in the next Kiali versions. So one of the first features that I would like to present and demo is that we have incorporated the support for TCP traffic shifting in Kiali. Right, so, and I guess this is the concept is quite easy, just to show to apply the same traffic shifting but for the TCP traffic. But I guess that I would like to show you this feature in an example. So this is my Kiali, my demo overview, and I have several demo applications with some complexity. So if one of these demo applications is the Traverse applications, it's quite typical microservices applications, right? But if you can see, in one of the service is just a data services. In this case, it's a MySQL database, right? And as you can see, the differentiation is that most of the services are talking in or HTTP or gRPC, which is the pretty usual, but all the backend services are just talking in the MySQL binary protocol in TCP with this database, right? So if I move into the version applications, I can run here. And one typical scenario what happened with databases is that at some point I have one version that runs slow. And what happens when your DBA or your database administrator is proposing, hey, I would like to optimize the scheme, so it's going to be transparent for your applications, but I would like to propose you a couple of new versions of the database scheme, but with new indexes, with new proposal that you should try to see some improvement in the performance of the global application. So now, one action that we can do in the context of the service mesh is go to the details of the service. We can click into the action, and we have also enabled TCP traffic shifting. So we can say, okay, I'm going to send 50% of my traffic to the original database, but I would like to combine 25% between the version 2, version 3. And when this is in place, I go back to the graph. I'm going to click here. I'm going to enable, for example, the new request rate or the new distributions. And I will see how it's working, right? How the traffic is flowing across these database services. And one next step that I can check is later examining the metrics to see, okay, if the two new proposals from the database administrator are better than the original one or worse, right? So this is one of the use cases, more specific use cases that we can see using Istio with binary traffic, in this case with a database, right? So this is already in Kiali, and you will see in the next version. So one of the following features that we have introduced in this sprint is also in the traffic shifting feature, but also to enable to do mirroring. The concept of mirroring is to choose one particular workload to send a replica, to send a copy of the message. So I'm also to present this with an example as well, I guess. Be clear. So let's go to an example, right? Let's go to my versions. I'm going to see if I have more versions for TCP. Okay, so I have the travel service, right? I guess that you can see in here. So I have a travel service with 3 versions, right? Version 1, version 2, or version 3 that I deploy, right? And this travel is being invoked by other user, other consumer, like the travel portal called Viaggi, the travel portal called Voyage, and the travel portal. So at some point, I would like to say, okay, I'm going to send all the traffic to version 1 and version 2. But imagine that the version 3 is quite experimental, and I want to put a mirror in the meaning that it's not going to participate on the real traffic, but every time that this service receives a request, it's going to copy to the version 1, version 2, but also to send a copy on the version 3. So it can help to perform some kind of new test or live testing, just creating this like a mirror. How we can do that? In the very same thing. So we can enable this or using the request routing or using the traffic shifting, and we need to select one of the workloads, like the mirror, right? And when we select one workload like the mirror, so the 100% of the real traffic is going to balance in the non-mirror workload, for example, 50% between this travel 1 or travel 2, or we are going to increase in 75% to the travel 1 and 25% travel 2. But we can decide that we are going to send 50% of this request to the mirror, right? So we are going to take the Travels version 2 versions, like a new version that I'm evaluating in a mirror mode, and I'm going to send some traffic to see, okay, how Travels version 3 is working. But it's not, I wouldn't consider that the version 3 is in production. It's like, okay, it's like a live testing, but it's not in production. For production, should be the version 1. So I create this one, and at this moment, what I'm going to see is that, okay, I have, let's go to the full graph again, and I have here, okay, I'm version, okay, I'm going to click into the version 1, and in this case, this one is going to be, the traffic is going to move in a mirror mode, okay? Okay, so let's continue with the features that we have for this sprint. So another feature that we have to include is to improve the correlation story between the telemetry and tracing signals in the details of the services, of all the elements in the service mesh. So as you know, the cycles in the service mesh are collecting multiple signals. Right? The two more common that we use is the telemetry, storing Prometheus, and also the tracing. What happens with tracing is that we usually have a lot of information, right? And we have a lot of tracing. And sometimes we would like to say, okay, but which is the trace? What is the spot? What is the interesting one? Which is the trace that I would like to compare with my telemetry? Because it could be the suspicion that something is slow, and I need to investigate more. So this is what we are correlating all this information in a visual way. So let me to show you that also in the example. Okay. For example, in this travels scenario, we can go to the details. We are going to see the inbound metrics. And a first correlation that we did was also to put together in the same charting the span durations with also with the telemetry metrics. And we can compare, okay, this is what is reporting the telemetry, and these are what is reporting tracing, right? If something is suspicious or, okay, is everything working under control, probably is yes, right? And the next steps could be also to take a look more close into the tracing signal. These are the tracing signal that I have for the last minute, that I can move to the last 5 minutes. And this is the chain, right? If this trace is slow or is good, is bad, right? Compare with that. And this is what we introduce here. We correlate with the telemetry information, just to give you, okay, it's seen that if I compare the duration of this trace with the histogram of the telemetry on the same period, probably it's okay, so it's not quite slow. But if I compare this order, I see that this is starting to show, okay, probably this is a little bit slower than the other. So I want to click here. And when I click here, I fetch the details of this trace, and I can also continue to have a more closer look into the comparison between, okay, how is this trace compared with other similar tracing? Is it slower or compared with the telemetry of the metrics, right? So it's seen that, okay, it's something between the 19 or the 99th percentile, but it's up to the average. So probably this trace was a little bit slow, and we can just to go deep there and see more details. What is the span or the suspicious? Or from here we can move into the Jaeger information, or we can go to get more details. For example, the logs. Try to understand why this trace or what this specific tracing request was slower than the others. Right? Continue showing features. So yeah, another feature that we introduced in this sprint is that we have a minor change in the displays option in the graph. So I guess that we have some rewarding to try to adjust better the meaning, and also introduce more icons with the tooltips with more explanation or all information that you're going to see when you enable these options into the graph. So this is new in these versions. Other minor improvements also to mention is that, okay, this sprint we have working to create to improve some performance issues around the Kiali operator, also to more performance issues about the backend calls, specifically for the Prometheus AP call, just to to more protections, to non-desired timeouts of the slow backends. We have a work in progress, an epic progress to multi-cluster support with feature that we will comment more later in other sprints, but around mesh discovery features, about new proposal for cluster traffic visualizations. More features that we are working in progress is to enhance the options in the graph to show the idle edges, or not to not show there when idle edges on the graph, to try to hide this traffic, this old traffic, this obsolete traffic, to have a clear graph of the visualization of your mesh. And more into the internal, more project settings, we are also considering to migrate from our CI systems from Travis to GitHub Actions. It's a work in progress, so we are doing POCs and also comparison with the previous system, and you will see some change in that area. Okay. I think that's for me, so I'm going to stop sharing, and I'm going to give the mic to Xavi.
Okay. Yes, let me share the screen. Okay, so I guess you see my Kiali, right?
Yeah.
All right. So here what we have is I like to talk about this new feature about showing the Envoy config that we introduced at last sprint, but definitely this one in this next release, this is going to be included here. So let me a little bit see with you real case scenario for see this feature in action, right? So here we have an application. It's similar that Lucas showed you, the travels agency. And for example, let's see the again the traces of one of one of the applications. If we go here, what we see is like we have a few traces, all right, and everything looks kind of all right. But if we go to the Jaeger UI, we can see, for example, that in hotels, I would like to add some extra tags in here for the troubleshooters, for the developers, or for admins to have more information about what's happening in every span in the application, right? So in order for me to add these custom tags, what I can do is go to the deployment, for example, of these hotels and add one. Let me see. I'd like to add some custom tags in here. There's one new feature in Istio that allows you to add this one. So what I'm gonna do is here in the annotations, in the metadata annotations, I'm gonna paste this one, this custom tags, right? So this is what you have to do in order to add extra config for the tracing. You go to this annotation, the proxy Istio config, and under the tracing field, you can add the custom tags, header, that you can add this portal one, device one, user, and travel, and also you can increase the sampling rate. This 95% is just for demo purposes. It is for me to show you like more samples, not just one every 10,000, but it's more like 95% of tracing. So okay, let's modify the deployment. I'm modifying the deployment, and then Istio will take this annotation and send all the annotations, all these custom tags to the Envoy. So let's go to the graph and see if something has changed. Let's see the animations in here, traffic animation. Okay, it looks like yeah, the hotels is receiving some traffic. I'm gonna increase the traffic a little bit for speeding up some traces. And yeah, let's see if we can see the new tags in the traces. Okay, so 19, I changed the sampling, so the sampling, it should since it's higher, we should be seeing traces right now, unless we've done something really wrong, because we've seen here some traffic. No traffic coming in here. Let's see if we can go to the Jaeger UI and find if there's also traffic here. Let's see this one. What time was that? It was 16:18, so I guess it was the previous. So it looks like there's no traffic, that maybe we've messed with something. Let me move this one. No traffic in here. No traffic in here. So yes, it looks like this update, something happened, something made to the Envoy. So let's go to the workload itself, and let's see the specific, if Istio has applied those custom tags into the Envoy itself. So here it's the new Envoy config feature we introduced last sprint. And here we can see, we can analyze all the Envoy configuration, how this Envoy is configured for this particular pod. And what we want to see is go to the bootstrap and look for the proxy config field in here, which is in the bootstrap section. And what we see is like, yes, the traffic under the tracing field, it has performed the update. Okay, custom tags. It looks like kind of all right, but something is not working. let's check how is the tracing section implemented for the other workloads in my mesh. So for example, going to the discounts, I can also inspect the Envoy and go to the bootstrap. And again, look for the proxy config, which is all the Istio configurations for that. And in the tracings, what I see here is that there's we've missed or we've override the zipking address. So what's happening now is that all the traces has been created, but not Istio didn't know where to send it. So okay, that's the main problem, I think, because shouldn't be any traces in the hotels. Nope, nothing yet. So let's edit again. Let's look for the sampling and let's add this address in here, and let's see if we are right and this was what was missing. So adding this, we should announcing to Istio that this Envoy, all the traces would be published in that service. So let's edit this one. I think the sampling still 95. So now we should see kind of okay. First of all, let's see. The hotel should be restarted. Yes, it's creating a new pod. Maybe my environment's a little slow, but yeah, I think we have it. Everything is healthy. So we could show again the bootstrap of the hotels one. Okay. And let's see if the changes has been applied. And yes, we still have the headers, the custom tags we mentioned, and also the zipking address registered in the Envoy. So this specific Envoy is properly configured for registering the traces. Let's see if we have traces now. And yes, after some time, we've added the new traces, and we see that everything at least is registered. Let's see if we see different results in the in every specific span. So if we go to a hotels span, now we should see that we have introduced these custom tags, right? So yes, we made it. With this example, the point was like there's a specific cases that when you're developing or administrating a service mesh that you need to troubleshoot your Envoy. And for that, what's best for you is to have really handy and really a few clicks far from you, a way to inspect what is happening in your cluster and in a specific Envoy, which are the listeners, which are the routes you have available, which ports, and for which protocols. So yeah, I guess that's all I wanted to show you for this sprint. Thank you.
Okay. You, Xavi, I get that next we are going to have Gary. Gary, I can share my slides for you.
Okay, thanks.
Okay, so I hope you can see the slide. So Gary, the mic is yours.
Okay, thank you. So part of this sprint, one of the main focuses we had was on the next major version of Jaeger. So there was a kickoff for that. And so we've had a number of design discussions around the new version, which is going to be based around the open telemetry collector as the main sort of building block for the various components within Jaeger. And we've got an initial POC that's currently got a build for the agent and the collector parts of Jaeger based on the Open Telemetry collector. So we'll be adding more capabilities to that proof of concept until it gets to the point where it's a very similar sort of functionality as the current version of Jaeger. We're also, for the next sprint, we'll be kicking off the same work, but on the version 2 operator, and that's because the operator framework has done a major change for 1.0, and it's now based on Cube Builder. So now's a good time to basically do a rewrite of the existing Jaeger operator to be based on Cube Builder and the new approach. We've also we've got a background task where we've been looking at alternative storage solutions because our preferred solution at the moment for production is Elasticsearch, but a number of users have expressed an interest in finding an alternative that's not as complicated to manage and resource intensive. So one of the things we've looked at this sprint is the Grafana TempoDB, which is a storage solution they're using that's can plug into Jaeger. And then in terms of other things going on, there's been some sort of general housekeeping things, and because the Open Telemetry project's quite fast moving, but because it's pre-1.0, generally every release has a number of breaking changes. So we've been trying to keep up with all the changes that are going on there and keep up to date with the versions. And then there's also been a number of bug fixes that we've been looking at over this sprint, and they're listed here. Okay, thanks.
Thank you a lot, Gary, for the update. So yeah, I'm going to stop the recording and start